Hello students, in this class we are going to learn how to find domain of a function. So basically let us know what is domain of a function is. The set of all x value such that fx is well defined or makes sense is called domain of a function. Means for all those x value for which fx is able to produce some real number is known as domain of the function. For example, here we have two functions. This is simple linear equation. Fx equals to 2x plus 1. Here it is a quadratic equation. So this function is defined for all real value of x. Means whatever real number we put, we get some real number. So domain of this function is simply set of all real number. Similarly, domain of this function is again set of all real number because this function is defined for all real number. Let us see few more question. Again, this is a simple square root function. Here our function is fx equal to square root of x minus 4. So this function is well defined, or we can say fx is well defined if x minus 4 is 0 or more than 0, because we know square root of a negative number reduce complex number and we are working on set of real numbers. So this function is not defined if whatever is written within the root is negative. So this function is well defined if x minus 4 is more than or equals to 0. How we solve this? Simply add 4 on both sides. We get x is more than or equal to 4. So what would be the domain of this function? Domain of this function is simply set of all real number that is more than equal to 4. So we can rewrite this as 4 to infinity, or we can rewrite this as our domain is basically x such that x is more than equal to 4 and less than infinity. Let us see one more example. Here we have a function fx which is equal to square root of x square minus 4. In order to make sure that fx is well defined or fx makes sense, fx is well defined if whatever is written within the square root should be more than or equal to 0. X square minus 4 is more than equal to 0. How we simplify this? We can rewrite this as x minus 2 into x plus 2 is more than equal to 0. Please note, if we put x equal to 3 in this equation, then this term is positive, this term is also positive. And if we put anything which lies between negative 2 to 3, for example, let us put x equal to 0, then we get a negative number. So basically, any number which is more than 2 or less than negative 2 is the solution of this inequality. So how we write this? So basically, the inequality which satisfy this is x is more than 2 or x is less than negative 2. At x equal to negative 2, we get 0. And at x equal to 2, we get 0. So what is the domain of this function? Domain of this function is basically minus infinity to negative 2 union. Negative 2 is included, so we put a square bracket union 2 to infinity. This is simple domain of this function. Let us see few more examples to understand such questions. So here we have a square root of 4 minus x square. So this function is well defined if whatever is written within the square root is positive. So we simply write fx is well defined. Fx is well defined if 4 minus x square is more than or equal to 0. Or we can say 2 plus x 2 minus x is more than or equal to 0. If we put 2 plus x equals to 0, we get x equal to -2. Once we put 2 minus x equal to 0, we get x equal to 2. So on a number line, here we have -2. Here we have 2. At -2 and 2, we get 0, which is fine. If we put any number lies between -2 to 2, for example, if we put 0, then we get 4, which is more than 0. So x value, so basically our function is positive if we choose any number lies between -2 and 2. And if we choose any number which is more than 2, for example, if we put 3, then this becomes 5 and this becomes -1. So this product is negative. Similarly, if we put any number which is less than -2, again, this product is negative. So basically, x which satisfies this inequality becomes -infinity to -2, where -2 is included because value of this function is 0 at x equal to -2, union 2 to infinity. So this is our domain. So domain of this simple function is, domain of this square root function is -infinity to -2 union 2 to infinity. Let us see one more example. Here we have a function fx equal to x square plus 3x minus 28. So we know even this function is well defined. Fx is well defined if x square plus 3x minus 28 is 0 or more than 0. So once we factorize, we get x plus 7 into x minus 4 is more than or equal to 0. Once we put number line, so here is -7, here is 4, this is say infinity, this is -infinity. Once we put a number lies between -7 and 4, say once we put 0, we get negative number. Once we put a number more than 4, say 5, we get positive number. Once we put a number less than -7, say -10. So once we put -10, this is negative, so product is positive. So basically x which satisfy this inequality is -infinity to -7 union 4 to infinity. So domain of this function is simply, domain of this simple function is -infinity to -7 union 4 to infinity. Hopefully all of you are able to understand this. Let us see few more questions so that we are able to understand it properly. Here it is a rational function. You know, gx does not make any sense if our denominator is 0, because if our denominator is 0, our function becomes infinity, which is not defined. So we say basically gx is not defined. Gx is not defined when x minus 2 equal to 0 or when x equals to 2. So basically we can say domain of this function g is anything except 2, right? Domain of gx is simply any real number minus 2. Let us see one more question. In this function, our denominator is x plus 3. It should not be 0, otherwise fx becomes infinity, which is not defined. Plus, this should be positive because this is within the square root function. So it should not be negative, otherwise it produces complex number. So we simply say fx is well defined when x plus 3 is strictly more than 0. Why not equal to 0? Simply because it is in the denominator, and when something is in the denominator is 0, our function becomes infinity or not defined. So x plus 3 is more than 0. Subtract 3 on both sides. We get x plus 3 minus 3 is more than 0 minus 3, which becomes x is more than -3. So domain of this function is simply -3 to infinity, and please note that -3 is not included. See few more example. Here we have a function gx equal to square root of x minus 1 upon x square plus 1. Please note x square plus 1, since x square is always more than equal to 0 for all x belongs to real number. We all know that being a perfect square, it cannot be negative. Now add 1 on both sides. So x square plus 1 is always more than or equal to 1. It means our denominator cannot be equal to 0 for all x belongs to real number, right? So basically we have no problem with denominator. It is always a positive number, either 1 or more than 1. Now our numerator is basically square root of x minus 1. Okay, so we say simply GS is well defined, since Gx is well defined. Oh, I just read defined twice. Gx is well defined when x minus 1 is more than 0 or equals to 0, since square root of x minus 1 is in the numerator, so it can be equal to 0. Now adding 1 on both sides, we get x is more than or equal to 1. So basically our domain is set of all real number that are equal to 1 or more than 1. So 1 to infinity is our simple domain. Let us see one more question. Here hx is square root of x square square root of x minus 4 over x square minus 25. So we know if our denominator is 0, then hx is not defined. So hx is not defined if our denominator is 0, because anything upon 0 makes no sense because we get infinity, or if x minus 4 is less than 0, then our function is not defined. So from here we get x equal to plus minus 5. So if x equals to plus minus 5, then our function is not defined, or if x is less than 4, then our function is not defined. So when this function is defined, if x is more than 4 and x is not 5 or -5. So what would be our domain? So h of x is not defined if these two things is happen, or we can say hx is well defined. Hx is well defined if our numerator is more than 0, if x minus 4 is more than equal to 0, and our denominator is not 5 or -5, and x is not equal to 5 or -5. So from here we get x equals to x is more than equal to 4 and x is not plus minus 5. So combine these two results together, we can say domain of this function is, domain of h of x is basically 4 to infinity minus plus minus 5, or we can rewrite this as 4 to 5 5 is not included, union 5 to infinity. We cannot reduce -5 from 4 to infinity because -5 is already included from the set 4 to infinity. There is no -5 in this set. So basically we can rewrite this 4 to 5 union 5 to infinity. Basically we exclude 5 only. Except 5, this function is always defined. So this is the domain of hx. So today we have done some basic domain. In the next video, I will tell you how to find domain of composition of function, or when we add two functions together, then how we find their domain, and how question come based on domain in the next class. Let me tell you few more things. If you have any standard function like exponential function, polynomial function, or modulus function, then our domain is obviously set of real number because these functions are always defined. Here I give you only two examples. One is 2x plus 3, and in this example, this is simple quadratic function. You can write any polynomial of any degree. Our domain is always set of real number because these polynomials are always defined. They always produce some real number once you insert some real number in place of x. Hopefully you will find this simple video helpful. And if you do find it helpful, then please subscribe this channel and make sure if you have any problem, then let me know in the comment section. Thank you.